Aloha, Richard Halverson here. This is ITS128, and today is the third class we're holding this week. Just to catch up, we're going to try to finish up a chapter, at least covering the text of chapter 4, I believe. Let me share my screen. And let's see, 128, here we are. Let's see, it is the right time, right? Thursday, 9:23. Yes, this is 9. Okay, so go to the syllabus. And we are in 9:20. We're in here, or finishing up branching. I think I'm going to try to finish up branching today. And if I don't get to any lab activities, don't worry, I'll do some next week. Next week is another starting of another 2 weeks for chapter 5. And so let's see where we were. Let's see where we left off last time. I'm going to go to my YouTube playlist and look at the last one. It looks like 4.48. If we go here, I can I'll go over here. And look up at the top. Oh, well, this is where I'm starting. Oh, it's starting at the beginning. Okay, so I'm starting out here. But if we go to the end, and I do this every time just to show you, just to remind you, because not everybody watches all the videos. I think most people watch the videos that they need to watch to be able to do the assignments. But you know, we're all busy, and you don't overdo it. So what you do is you look at any place on the video, and you look up at the top, and this is 4.5. So we're talking about 4.5 here, and this is just to keep you. So if there's a section you don't understand, or if there's a challenge activity that you don't understand or something, then you can go and find it this way. I try to do the starting of every one. Like I'll do the first one, and I'll do the first challenge activity and so on. All right, so it does look like 4.8 is as far as I got. And so let's continue on from there. So I will click on the textbook. And what's after 4.8? 4.8. This is where we ended up last time. We're in 128. So let's start with we talked about common errors, right? Comparing data types, and this can lead to common errors because Python is strict about mixing data types. Like if you see 1, 2, 3, is that 3 characters, the character 1 followed by the character 2 followed by the character 3, or is it the number, the value 123, and something where if you add 5 to it, it ends up being 128. And so if you want to print out something that's got numbers and characters in it, you can't just be lackadaisical. You have to convert numbers to strings. And Python is strict about that, and there's advantages for the programming language to be strict about it. PHP doesn't care, for example. But you can run into problems when languages don't care about certain things. So, all right, so let's go to membership and identity operators. Okay, so there's some more operators, and that has to do with when you're dealing with lists and sets and tuples and so on. So there's the in and the not in operators, and so it's something is either in a set or not in a set. So the result is going to be true or false. So you can click through this and just what's this supposed to, what are you supposed to get out of this? So someone types that in, and it creates these 3 places and puts those in there. And notice this is 3 characters, and this is a number, and this is a number. What's next? Okay, then somebody says, oh, I see. print. Okay, so this is an expression. Yeah, there's no quotes around here. So if I go like this, CMD, and open up Python just like this, and say, let's see, Python, and I say prices equals left square bracket, quote, $20, end quote, comma, 15, comma, 5, close the square bracket. So now I've created a list. And now if I were to print, see, I'm not printing this. Yeah. Okay. I don't mean to print that. I mean to print the value of the expression, the value of this expression, and the expression is 15 is in prices. So print whether or not, print if it's true or false that 15 is in prices, and it's true. How about like this? How about if I go is 20 in prices? No, it's not, because of that, because it's not 20, it's this $20 thing. So print, now watch, this is not going to work. $20 in prices. It's not going to know what that means. So he doesn't know what that means, because it's not $20, it's print quote $20 quote in prices. Is that in prices? Well, yes, it is. So it's the first one. All right, anyway, that's pretty cool. Just to bring that point home. All right, so so here we're doing some more on members. So you create a list of names, and then we're writing a program here, and we ask the user to enter in a name, and then we test it if the name is in there, and if it is in there, it says found, and then the name is on the roster. This is the roster. Otherwise, it says no, it's not. And so, you could use the not operator because it's the opposite. The in operator and the not in operator is the opposite. That's all. Membership operators can be used to check whether a string is a substring. Oh, well, that's nice. Okay, so that just means okay, so this is how you test if a substring is within a string. Well, that's pretty nice. So like if you want to test to see if this is in this, you can just use the in operator. Okay. All right, so this is how you check if membership in a dictionary. You're asking if you're asking if a key value is in the dictionary. You are a key. You're asking if a key is in the dictionary. Okay, this is the key, and these are values. Okay. Okay, so you aren't asking if a value is in the dictionary. You're asking if a key is in the dictionary. So this is a key, and so is this in the dictionary? Well, yes, it is. But is this in the dictionary? Well, no, it's not, because it's not a key. It's got to be this, this, or this, and so the answer is no, and so 3 is not found. You see. Which expression checks whether the list, my list, contains the value 15? Checks whether the list contains the value 15. Well, I guess it's this. Yeah, all right. Which expression checks if the value 10 exists in the dictionary? No, I guess none of them. There's a different way to find that out, and we'll get to. All right, and then there's is and is not. So this is unique to Python because we're dealing with objects, and they make a point of that. And so this is just testing. Here you test if two variables are actually pointing or addressing the same object. So you test if these two things are the same name or are just two names for the same object. And it's explaining that here. It's not comparing the object values. It's comparing whether it's the actual object. So it would be like the memory address. It's like I don't know. It's like this is a dumb example, but I live in a neighborhood where there's like 3 other houses that are just exactly like mine, except for they're on a different block facing a different way. And so my neighbor Clifton, okay, is his house equal to my house? Well, they were created from the same blueprints. So the answer to that is yes, but is his house my house? No, it's not, because his house is a different object of my house, and that's kind of what they're talking about here. Anyway, all right. A common error is to confuse this when you mean this. Okay, so is my house equal to Clifton's house to be like this one, and is my house Clifton's house? No, it's not. So it would be not is. So anyway, and in Python you distinguish that and with these operators, and I guess I don't have an experience writing code where I would want to make a distinction between that, and that's because this is not a common feature in programming languages, and I've never done it before. But as always, there's probably times when the programmers are so glad that it has this feature. All right, so let's do a challenge activity. What are they asking here? Let's see. Let's do one of these first. Key X is a key in. Okay, write the simplest expression that captures the desired comparison. X in my dictionary. Yeah. Are unique objects. Okay, so that means they're not the same object. So X is not Y. Oh yeah, what do you know? Okay, so that's that. So let's start this. I already clicked check. Type the program's output. Okay, so these are the numbers. We have a list of numbers. In other programming languages, this would just be called an array, but this language we call it a list. So we want to read it in, and we want to see if what we read in is in this list. Well, if X read in as 5, X is not in the list. So If X is in numbers, it prints in, and if X is not in numbers, it prints not in. So what we're going to print is not in. Enter. Yes. Because 5 is not in 4. Okay, let's do one more. Okay, here's another set. In, not in is, okay, 15. Is 15 in numbers? No, it's not in numbers. If 15 is not in numbers, then print not in. Okay, well, this is just too easy. So I'm going to try to do this, and I'm not going to hit the enter key, just as somebody was asking yesterday. Oops, darn. Okay. It's going to give me another chance, isn't it? All right, I'll just give it the right answer. Okay, so here's another one. Write an expression using membership operators that prints special number if special num is one of the special numbers stored in this list. Okay, so these are special numbers. Okay, so and the input is this, and it's not a special number. That's great. So we have these special numbers here. Then we ask this list of special numbers, and we ask the user to give us a number, and we're going to test to see if it's special or not. And so we're supposed to type some code in here. So if special num, if special num is in special list, that's all. If special num is in special list, then it prints out special number. Otherwise, it prints out not special number. So 17 would print that out. So let's see if it's right. Yes. All right. What's next? Order of evaluation. Okay, so this is pretty important, and this is the same. This is the same as every programming language around today. Every programming language that's around today. There have been programming languages in the past where they have not been this way, but actually these ands and ors. But and it has to do with if you have some sort of expression, you know, how do you evaluate it? Which operations do you do first? It's not always left to right, because lots of times if it's left to right, it's not going to make sense. So here we have, well, it's okay. So this is an example of, well, anyway, here, the first thing you look at, of course, is parentheses. You should know all this from algebra, but in case it's been a while since you've done your algebra, you know, there's a lot of these. I don't know if anybody here follows Twitter, but there's a lot of these Twitter quizzes that these people come along and they've got this expression, and you're supposed to evaluate the expression and say what the final number is. And people always have numbers all over the place, and it's because they don't follow the order of precedence of operations, and that's all it is. So if there are parentheses, you do what's inside the parentheses first. Okay, so here we have in this expression, we're going to do this one first, and that's going to evaluate to some single number. And then so there'll be a single number here now, and then we do with the next parentheses, which would be these outside ones. And so that would be A times whatever that single number is. And then we have that single number, and then we're going to subtract D from that single number. Now, if you did not have the parentheses, if you didn't have the parentheses, then the order of precedence would be what this is here, what this here, and And in this case, let's say there's no parentheses, multiplication has higher precedence. It's not this. It must be in a previous section. But it turns out that these three have precedence over these two. I can't believe it says in an earlier section. Must have been. Here, it must have been in here. Yeah, here is talks about order of precedence rules. So multiplication, division, and modulo has precedence over plus and minus. So anyway, let's go back to so anyway, that's all this is. This combines the arithmetic, logical, and relational operators. So here it's mixed up, yeah. Well, you're gonna do this side first and get some number, and then you're gonna do this. Okay, so all of these have precedence over any of these. So if you're looking at an expression and you got some of these and you got some of these, well, first you're going to do these. Okay, so here, first you're going to do whatever this is in the right order. And so first you'd multiply the 45 by the y. So you get, 45 times y. And then you'd subtract that value from z. And then you test if that value, that final value, which was subtracted from z, is that less than 53. Okay, so anyway, that's that. Here we have or, so you're going to do these before you do the or, because this is higher precedence. So if you have something like this, first you're going to evaluate this, and it's going to be a true or false, and then you're going to evaluate this, and it's going to be a true or false. And then, so not has precedence over anything. So you're going to do the not on the y first, and then you're going to or it with, you're going to do the not on the x first, and then you're going to or it with the y. So you're not going to do this first and then take the not. Okay, so you're going to do the not on the x first, and then you're going to or it with the y. And if you have ands and or, if you have ands and ors in an expression like this, you evaluate the ands before you evaluate the ors. And has precedence over or, just like multiplication has precedence over addition. All right, so these are, this is another way of expressing order of precedence, in a tree. So if you have something like this, first you're going to add the x with the 1, and over here you're going to multiply the y times the z, and then you have a value here and you have a value here, and then you're going to do this comparison, and you're going to end up with a true or a false. Meanwhile, over here you've got two values here, and you're going to compare if they're the same, and if this is either going to be true or false. And so at the very top here, you have a true false and a true false, and you take the or of them. That's the result of the whole thing. So that's what that is. So here you just want to say that the not is executed before the evaluated before the and so you can do these. Common error is missing parentheses. Equality operators Precedence over logical operators. Okay, so in this case, this is going to be done first, and then this is going to be done because this has precedence over this. Which illustrates the actual order of evaluation via parentheses. So, so this is actually, first this is done, then this is done. So if we were to put parentheses in there to make it unambiguous, where would we put them? And that they would be right here. So I guess what we mean to say is which one is equivalent? And it'd be this one, because this one is the same as that. And here, this last one is equivalent, because first you do the less than bats less than birds, and then you do the birds less than insects, and then when you're done with that, you do the or. So depending on which ones are true or not. So it's this one. All right, so you can do the rest of them. Okay, so here we talk about indentation. And that's what defines a block. In Python, it's the only language that I know of where indentation defines a block. In every other language, there's some other way to define a block. In most languages, it's curly braces. Curly braces define a block. But in Python, it's indenting from the line of code above it. So code blocks are a series of statements that are grouped together. A code block in Python is defined by its indentation level, the number of blank columns from the left edge. And so, so that's how you define the if part. If something is true, you do a block. But if it's not true, you skip over the block. Well, the way you know what skipping over is you go down to the next line of code that's at the same indentation level as the if. It's the only language that's that way. So if this is not true, then you go down to the next statement of the same indentation level, and that's this one. But if this is true, then you do what's inside the indentation. Okay, so this is a block. This is a block. Like that. All right, blocks. Fix the errors in the code below so you can run the program. Okay, so here we're import. It's probably not even liking this. Let's see what happens when I run. Oh my gosh, see, it doesn't even like that. It's the only language in the world. All right, so I fixed that. Now let's run it again. Oh, great. I got past that error. Now we're up to line 10. And what's the matter with this? Oh, it's the starting of a block. It's the starting of a block for no reason. All of a sudden, there's this block which is stuck in the middle. Well, you know, in other programming languages, you can actually put blocks. You can just throw another block. You put block. The enclosing of a block symbols around a bunch of code, and it doesn't matter. But Python's real picky about that, so we got to take this off. And I think we can still have that space. So let's see. Okay, same thing. So let's take that one off. Now we have another block problem right here. And so if we take that off, now it should probably work. Oh, else. Is there an else someplace? Oh, there's more code down here. You can see that. Okay, so we can get rid of some of the spaces. And okay, the else, yeah, it can't. The else has there's got to be an if at the same level above it, and there's not. See, this all of a sudden there's this else down along in this block, and so really, they mean that this else should be part of this if. So I'm going to make it. There we go. So now if, and then this. And here we have okay, let's see. There's going to be another indentation problem here and another one here, and this one's okay. Well, that's interesting. It'll either be that or this will be okay, but this will be the indentation problem. Let's see what the error is. Ah, see, this is the indentation problem. So if I make this the same indentation level, does that work? Okay, let me make this the same indentation level. Oh. Is that all this does? If it's less, oh, if the radius is less than that, it says we have a problem. If the radius is more than that, so let's put this in there. Let's put this in there. Okay. Well, anyway, you know, really, the indentation should be the same. So it really should be this way. And if you're using any kind of editor that knows you're typing in Python code, which most of them would, except for maybe Notepad, then it'll help you. And you also have to make sure that it's not like this is a tab and this is like 4 spaces. You know, that won't work. It'll call that out as an error. So this should still work. Yes, okay. And if we go um, 6999. Whoa. Okay. All right. So anyway, that's that. Special cases. Some indentations are continuations of the previous line. So I guess this is okay for clarity. This is okay. All right. Standard number of spaces is 4. Yeah, I guess, but it can be 1. That works. But I guess they want us to say true. Mixing spaces and tabs when indenting is considered accept. Well, I'm going to say false. Yeah, should never mix tabs and spaces. A programmer now, if you use a tool like Visual Studio Code, it'll fix all that for you. A programmer can start new code blocks at any point in the code as long as the indentation for each line in the block is consistent. I don't think we can we? Yes. Can only be started after a statement that ends with a colon. Oh, I didn't know that. A new code blocks may only begin after a statement that ends with a colon. That's a good rule. I guess that must be up here somewhere. All right, let's do a challenge activity. Let's see. Retype the below code. Fix the indentation as necessary to make the program work. Okay, so what this is we have this list called temperatures. Oh, look, here it is. No, I'm sorry. It's a dictionary called temperatures, and we're seeing if there is a key value pair whose key is New York. Is there one in there? And oh, look, there is. So if that's true, oh, look, this is actually gonna, I gotta see this working in action. Let me open up some code here. I'm gonna take this code. Okay, I'm gonna take this code, copy, and I'm gonna put that here, paste, and then I'm gonna take this code, copy, and I'm gonna paste it here. Okay, so if New York is in temperatures, then if temperatures tab is 90, then print, else print this, yes. And this else goes with this. I mean, this else goes with that, and we should indent just. See, now this takes care of, see, even though I used a tab, it actually put spaces in there, you see. Oh, and it put 4 spaces in there. Very nice. All right, so now what I'm curious about is this. When this thing executes, is it gonna ask, is it gonna sit there and ask for something? I'm gonna see. I'm gonna put this in here. Enter temperature for, I guess I gotta say New York. Okay. All right, I'm gonna run this and see what save and bring my command prompt up. And I'm gonna do exit CD OneDrive desktop ITS128, and there's my program. And so I'm going to run that by saying Python test2.py, and it says, oh, okay, so this is executing, and all of a sudden this pops up, and I will enter something. What should I enter? 105. Okay. 105. Okay, well, I should make that look better, but, and it says this the city is melting. Well, that's pretty cool that you can just do that. I should actually go like code space. Okay, but anyway, this fixes the syntax. And you probably have, let's see, Python syntax checker. Online syntax. Check Python syntax. Okay, I paste the code in there. So let's go over here, and I'm going to copy out this code here. Copy, and I'm going to put this in here. Paste. Huh? No, really? This is not working. Anyway, I thought I could find one, and there probably is one where you pop the code in there and it fixes the syntax for you. But anyway, so that's the answer to this one. So you can type this in, type this part in here, and it should be correct. This goes back, this goes back, this goes back to there, this stays there, this goes back to back here to where this is goes back here to where this is, and this can go back here, although it can stay here too. All right, so anyway, that's that. Conditional expressions, it's 12:10. Oh yeah, okay, so this is a unique statement. This is unique to Python. Other languages don't have this feature. So all expression when true if this condition, otherwise the expression when false. So this is an expression. So it's going to be, it can be on the, oh, this, yeah, this can be on the, oh, yeah, okay, great. So it's going to be, it's an expression, it's not a statement. So it's going to be on the right side of an assignment statement, and it evaluates to something, and it's going to evaluate to, depending on what this condition is, if this condition is true, then you evaluate this expression and set it in and store it into here. If this condition is false, then you evaluate this expression and store that value into here. So that's how it works. All right, so we're supposed to convert this into that. Well, I think it's something like y equals, oops, y equals, the condition is this. So I'm going to copy this bug up here. It's true. Oh, wait. Okay, this is, okay, so if it's true, you want it to be this. If this is true, you want it to be this. If this is false, you want it to be this. And this is what goes in here. And this is the true and this is the false. So we simply take this. Well, I'll tell you what, I'm going to start by doing this. Copy this and paste it here. And there's that. And then we have to put this expression-y thingy. Do I have to put it in parentheses? I guess I do. So I'm going to copy this and put that space. I wonder if I really have to put it in parentheses. Using parentheses around the condition. All right. Okay, there's the expression. Wait. Where's the if? There isn't it. Oh, this is just kind of dumb. Okay, so the if goes on the outside. If the condition, and then the false thing goes over here. So that would be X. This is if it's false. So that's going to go right here, right? So it's the first expression, and then there's if that. Oh, I have to have the word else also. Else. See, I don't use this. So you have to have this in the middle. And this is what happens if that's true, and this is what happens if it's false. Is this the right answer? Yes, it is. Right answer. Okay, how about this one? Real quick. This goes there. And then I do this. And I do this. And then I do this. Oops. And then I do this. And I put parentheses around here. Is that right? Yeah. Okay. All right. So let's do this one. I'll do the first one. My number is 4. Your number equals, so what is this? Is that true or false? Looks like it's true. It's true? Well, then it's this one. Wait a second. There's no parentheses around here. There should be a parentheses around this thing. Wow, is this true then? Do we really need the parentheses there? No, we don't need the parentheses there. Do we really not need the parentheses here? Oh, okay. All right. Well, so I guess we don't need the parentheses there. Anyway, so this is false. No, this is true because my number is in fact less than 4. So it's going to be 8. So your number is going to equal 8. And here we just print it out. So I'm just going to do 8, enter. Yeah, easy. All right, you can do the next two. All right, what's this one? We have conditional expression, print negative or non-negative. Okay, so this is the input, and it says whether it's negative or non-negative. All right, well, I guess that would be negative or non-negative. So if it's, so we read it in, and if it is true, okay, it's gonna either return negative, it's gonna return either the word negative, and then it's gonna be if, then it's gonna be something, and then it's gonna be the word else, then it's gonna be non-negative. Okay, and what goes in here? If user val is less than 0, then if this is true, then this is printed. If this is false, in other words, if it's 0 or higher, then this is printed. So I think this is right. I'm just going to run it and see. Yes, it is correct. All right, very good. Let's do this one. Maybe I won't do this one exactly right, but I'll get you almost there. Using a conditional expression, write a statement that increments user numbers if update direction is 3, otherwise decrements user number. So update direction. So, okay, first we ask for the number of users, and then we ask for an update direction. And if the update direction is 3, okay, whatever this is, if this comes in as a 3, then we increment number of users. We increment by 1. Okay, we could increment by more than 1. It doesn't say what to increment it by, but when you just say increments, you assume that they just mean 1. So if update direction is 3, then it increments by 1. Otherwise, it decrements it. Okay. So decrements. Okay. So the expressions are, if it's true, it's going to be something. And what is the something? Okay. So I'm going to do the true thing first, according to whatever it is, and the true thing is going to be num users plus 1. Okay, because that's what we want it to be if it's true. And then we're going to have this if something else. And what's the expression if it's false? Well, it's going to be we decrement num users minus 1. We're going to subtract 1. Okay, so if this is true, we're going to increment. This is going to be evaluated and get stored into there. If this is false, then this is going to be evaluated and stored into there. And what do we want this to be? Well, we want true to be if update direction is equal to 3. Yeah, and it's not is in the Python operator sense. It's equal. So if the update direction is equal to 3, then do this. Otherwise, do this. Let's see. Well, so let's see if, well, I'm pretty sure that's right. Here, let me copy this over. I'm gonna put here, and I'm gonna paste that here, and I'm gonna say enter number of users. Spelled all stupid, and this is going to be a direction. And so if we save this and we run it, number of users is 5, and the direction is 3, it's going to have a new value 6. However, if the number of users is 5 and the direction is something else, then it decrements 5 down to 4. Well, anyway, so you know enough to do that one. What time is it? So additional space. Okay, so we'll do this one, and then we can end, and I can do some of these. Well, why don't I do some of these now? You should go through this last one here. It's something where we you enter in an abbreviation and it prints out what it means. See? So you can try other things. All right, so let's do this one. Given integer values, subtract gray. Okay, so red, green, blue, those are the 3 primary colors, or not, but they're the 3 colors that you use to make all the colors on video. And so this is the intensity of red, this is the intensity of green, and this is the intensity of blue. And it ranges from 0 to 255. 250, you know, it's actually, you know, 8-bit numbers, or bytes. The value of a byte is between 0 and 255. So we got 3 bytes here, and so that's, and so if you have 0 intensity of all 3, it's going to be the color black. If you have white, all white, or maximum intensity of all 3, you have white. But if you vary certain things, it's going to be different colors. Like this is red, 130 of red, nothing of green, and 130 of blue, and that's going to end up being about a medium purple and dark. And if it's all, if all 3 of them are the same, then it's going to range between you know, white, gray, and black. Okay, so so if they're all the same, then you know it's going to be some shade of gray. And so the idea in this okay, and the lower the number, the darker it is. Excuse me. So what we're supposed to do in this is we enter in 3 numbers, and we're supposed to take as much gray out as we can. So to take as much gray out as we can, we have to take out numbers that are all the same number. Well, if this is read in, the most we can take out, because they all have to be the same, the most we can take out is 50. We take 50 out of here, it ends up being 80. Take 50 out of here, it ends up being 0. Take 50 out of here, it ends up being 80 again. So this is the result. So this is what we're trying to do. Too bad I can't like show you. Oh, maybe I can. Okay, so what do? We read in the 3 numbers, and then we keep track of the smallest one, and then we subtract that smallest one from all the numbers, and we end up with this. So we do something like, do I have to input it? I guess I just have to write this code. So I'm going to say red equals input whatever, and I'm not going to do this. Green equals input green. I like this. I like to know what I'm being asked. Blue equals input blue. And then I want to figure out what the smallest one is. So I'm going to do the, it's got to be integer. Int. We got to int this dude. Okay, int. Okay, so we got these 3 like that. Now, I also want to keep track of the smallest. So I'm going to say smallest equals, and the biggest smallest, okay, 300. Okay, so it's going to be smaller than 300. The max, it's going to be the max highest is going to be is 255. So now, if red is less than smallest, then I want smallest to equal red. And if actually these can all go at the end. This is for red. I need one for green, and I need one for blue. So this is going to be green. Oops. What is it? If green is less than smallest, then I want smallest to equal green. If blue is less than smallest, then I want it to equal blue. And so those are my three tests. And then all I got to do is say red equals red minus smallest. Green equals green minus smallest. And blue equals blue minus smallest. And then I got to write it out. Is that what I do? I got to print it out. Print red, green, blue. Let's see. So it's going to ask me for my red, which is, what am I supposed to say? Am I supposed to 130, 50, 130? You know, okay, so when you test this, you should try making the blue, the red one the smallest, and then try it again with the green one the smallest, and then try it again with the blue one the smallest, because you want to test every branch, every branch of your code. And yeah, so anyway, so let's do 130, 50, 130, just like it says up there, and let's see what happens when we run it. And what comes out is 80, 0, 180. Now, why did this come out, you say? Well, it's because we print it out here, and then we print it out here, and then we print it out here. And so really what happened was, first this printed out, and then it's gobbled this up. And then after that, this printed out, and it gobbled this up, and then this printed out, and it gobbled this up, and then it printed this out. If we were to run this here, we were running here, save, run. Oops. Run would look more like this. Red is 130, green is, let's say, 50, and blue is 130. Enter, and it prints out this 0 or 80, 0, 80. So this really is more like how your program is going to run. This is a cute, clever way of making it real easy. So even if you can do your lab assignments on your iPhone, on the bus or something, you can even do that with this. That's nice. But as I mentioned before, Zybooks is working on this to make an interface that looks more like this. But anyway, all right, so it's 12:30, and I have finished chapter 4 and done lab 4.14. And next time I'll probably jam out some more of these labs just at the beginning of the class, maybe next time, before we dive into chapter 5. So are there any questions? All right, well, thank you for coming, Beverly. It's always nice to have a visitor, but today I thought was going to be the first day of this semester where nobody shows up. I'm sure there's going to be more of those, and in my 148 class, it's going to happen. But anyway, thanks for coming, and I'll see you next week, maybe. Take care.
You too. Thank you.